What's up guys, this is Massey. Welcome to another video. In this video I want to show you some examples regarding balancing chemical reactions. The first example I have here, it says write the balanced chemical equation for the reaction of sodium in oxygen to produce sodium oxide. Sodium is Na, oxygen is molecular oxygen is O2. It's gonna produce sodium oxide. Sodium oxide is Na2O. Why Na2O? Because oxygen, the charge for oxygen is 2. The charge for sodium is 1. So we need 2 sodium atoms to react with oxygen. So we write 2 for here and 1 for here, and we don't write 1. We just don't write anything, which means that it's 1 already here. Now we need to balance it. We have one sodium in this side, and we have 2 sodium in this side. So I'm gonna write 2 in here. So now it's gonna balance for sodium, and we have 2 atoms of oxygen in the reactant side and 1 atom of oxygen in this side. So I'm gonna put 1/2 to make it 1, and we have 1 in here. So right now it is balanced for both sodium and oxygen. And since we want to get rid of any fraction, we need to multiply all the coefficients by 2 in order to make all of them an integer. So it's going to be 4 sodium plus O2 gives us 2 Na2O. So we have 4 sodium, 2 oxygen, 2 oxygen. And by the way, this is a synthesis reaction. This reaction is a synthesis reaction. Now, next example. Write the balanced chemical reaction between hydrogen and oxygen. So hydrogen is H2, oxygen is O2. So this is gonna produce water. So we have 2 hydrogen in here and we have 2 hydrogen in here. So hydrogens are already balanced. What about oxygen? Oxygen, we have 2 in here and we have 1 in here. So we're gonna make it half. So oxygen is balanced now. So in order to get rid of this denominator, we multiply everything by 2. So 2H2 plus O2 is going to give us 2H2O. So we have 4 atoms of hydrogen here, 4 atoms of hydrogen here, 2 atoms of oxygen here, 2 atoms of oxygen here. So this is the balanced reaction. So that's a synthesis reaction. Next example, write the balanced chemical equation between nitrogen and hydrogen. So it's going to be N2 plus H2, and that's going to produce ammonia. NH3 is ammonia. So we have 2 nitrogen in here. So we need to have 2 nitrogen in here. So it's going to be Na plus H2 gives us 2 NH3. Then here we have 2 times 3, 6 hydrogen. So we need to have 6 hydrogen here. So N2 plus 3 H2 is going to give us 2 NH3. Now it is balanced. Next example is going to be the chemical reaction between copper and silver nitrate to produce copper 2 nitrate and silver. So copper is Cu, silver nitrate is AgNO3. That's going to give us copper 2 nitrate, so it's going to be Cu is copper, nitrate is -1, Cu is 2, so it has to be 2 in here and 1 in here, plus Ag. So how we balance it? Copper and copper, 1 and 1, so it is already balanced. Copper is balanced. We need to balance nitrates. We have 2 nitrates and here we have 1, so Cu plus 2Ag and O3 is going to give us Cu and O3 2 plus Ag. So now nitrates and coppers are balanced. The only thing is remaining is Ag, so we need to put the 2 in here. So it's going to be Cu 2Ag and O3 gives us Cu and O3 2 plus 2Ag. Now everything is balanced. So this is a single displacement reaction. Now balance the following chemical equations. First one is P plus O2 is going to give us P2O5. So we have 1 atom of phosphorus here, 2 atoms of phosphorus here. So I'm going to place 2 in front of phosphorus. So phosphorus is balanced. We have 5 and 2 in here. So I'm going to place 5 over 2. 5 over 2 times 2 is going to be 5. So now it is balanced. The only thing is remaining, we need to multiply everything by 2 in order to get the denominator. Get rid of the denominator. So 4P plus 5O2 is going to give us 2P2O5. This is a synthesis reaction. Next one. K2O plus H2O is going to give us KOH. So we have 2 potassium atoms and 1 potassium atom in the product side. So I'm going to say K2O plus H2O is going to give us 2 KOH so far. Now we have 2 potassium atoms, both sides, 2 oxygen, 1 and 1, 2 in here, and 2 hydrogen and 2 hydrogen. This is already balanced. This is a synthesis reaction. Next one. AlBr3 plus K2SO4 gives us KBr plus Al2SO4 3. So right now we have 2 Al here, 1 in here, so we need to place 2 in front of AlBr3. Then we have 3 in here. We should place 3 in here as well. So 2AlBr3 plus 3K2SO4. It's going to give us KBr plus Al2SO4 3. Now potassium, we have 3 times 2, 6 atoms in this side and 1 in here. So we need to place 6 in here. So 2AlBr3 plus 3K2SO4 6KBr plus Al2SO4 3. Now let's check everything. Al, we have 2 and 2, that's good. Br, 6, 2 times 3, 6, and here we have 6. K, 3 times 2, 6, 6 in here. SO4, we have 3, and we have 3 in here. So now it is balanced. This kind of reaction is called double displacement. This is a double displacement reaction. Next one, FeCl3 plus NaOH gives us FeOH3 plus NaCl. So we have Fe 1 and 1, that's okay. OH, we have 3, we must put 3 in here. So FeCl3 plus 3 NaOH plus FeOH3 plus NaCl. We should put 3 in here this time because we have 3 sodium. So it's going to be FeCl3 plus 3 sodium hydroxide is going to give us FeOH3 plus 3 NaCl. So we have Fe and Fe 1 and 1, Cl 3 and 3, OH 3 and 3, and Na is 3 and 3. So that's balanced, and it is double displacement again. So this is a double displacement reaction. Now, next example. AgNO3 plus H2S is going to give us Ag2S plus HNO3. So Ag, we have 2 and we have 1 in here. So right from the beginning, we place 2 in front of silver nitrate, H2S, sorry. So Hg2S plus HNO3. We have 2 hydrogen atoms and we need to have 2 in here. So 2AgNO3 plus H2S is going to give us Ag2HNO3. So now we have 2 nitrates, 2 Ags, 1 S on both sides, and everything is balanced. Very good. And this is also a double displacement reaction. Next, NH4 2CO3 gives us NH3 plus H2O plus CO2. NH4,2CO3 is ammonium carbonate, ammonia, water, and carbon dioxide. This is a decomposition reaction because we have one reactant and more than one product. So it's going to be decomposition reaction. So NH4, we have 2 of them. So we need to put 2 in front of ammonia, NH4. CO3, we have 1 of them and we have CO2 in here. So 1 on 1, that's balanced. So let's check out the hydrogen. Hydrogen, we have 4 times 2, 8. Here we have 6 plus 2, 8. That's good. The oxygen is remaining. Oxygen is 3. And here we have 2 plus 1, 3 as well. So that's already balanced. So this is a decomposition reaction. Now let's see another example. Balance the following chemical equation. First one is S8 plus O2 is going to give us SO2. So we have 8 sulfur in here. We need to have 8 in this side. So S8 plus O2 is going to give us 8SO2. 8 times 2 is 16. So we need to have 8 in here as well. So we have balance, and this is a synthesis reaction. Next one. Na plus H2O is going to give us NaOH plus H2. So we have 1 and 1 oxygen, 1 and 1 nitrogen. We have 2, but in here we have 3. If I put half in here, everything is gonna be balanced now, because it's gonna be 1 and 1, 2 hydrogen, 1 oxygen, 1 sodium, and 1 sodium. So we need to multiply everything by 2, so to balance it, 2 Na plus 2H2O is going to give us 2 NaOH plus H2. Here's the single displacement. Next one is lithium plus AlCl3. It's going to give us LiCl plus Al. Lithium plus aluminum chloride give us lithium chloride plus aluminum. So we have 3 chlorine and 1. So I'm going to say 3 LiCl. Li's are balanced. Cl's are balanced. The only thing is not balanced is Li. So 3 Li plus AlCl3 is going to give us 3 LiCl plus Li. Now it is balanced. Next is going to be C4H10 plus O2. It's going to give us CO2 plus H2O. That's the complete combustion of butane. So butane plus oxygen is going to give us carbon dioxide and water. We have 4 atoms of carbon, so we need to have 4 in here. So C4H10 plus O2 is going to give us 4 CO2. Now we need to balance hydrogen, so we have 10 in this side, we need to have 10 in this side, so I need to put 5 in front of H2O. Now we need to count oxygen atoms on both sides. Here we have 8 and 5, it's going to be 13. We have 13 oxygen atoms on the product side. So we need to have the same thing here. So I need to multiply this. Since we have 2 in here, we need to multiply by 13 over 2. So C4H10 plus 13 over 2O2 give us 4 CO2 plus 5 H2O. Now if you want to get rid of the denominator, we need to multiply everything by 2. So 2 C4H10 plus 13O2 gives us 8 CO2 plus 10 H2O. And this is called combustion reaction. Combustion reaction. Next, N2 plus O2 gives us N2O5. Nitrogen, oxygen, dinitrogen pentoxide. So N's are balanced. I need to multiply this O2 by 5/2. Then if we want to get rid of these 2, we need to multiply everything by 2. So 2N2 plus 5O2 gives us 2N2O5. We have 4 atoms of nitrogen, 4 in here, 10 atoms of oxygen, 10 atoms of oxygen in here. We have synthesis reaction. Next one is Li plus B2O3. It's going to give us Li2O plus B. So we have 3 oxygen in this side. So we need to have 3 oxygen in this side as well. So Li plus B2O3 is going to give us 3 Li2O plus B. B, we have 2 in here. We must have 2 in there too. Li, we have 3 times 2, 6. So 6 Li plus B2O3 gives us 3 Li2O plus 2B. Yeah. Next, we have Fe2O3 plus H2SO4 gives us Fe2SO4 3 plus H2O. So we have 2 in here for Fe, that's balanced. Hydrogen is also balanced for now. Sulfate, we have 1 in here, we have 3 in here, so I need to put 3 in here. So Fe2O3 plus 3H2SO4 gives us Fe2SO4 3 plus H2O. So since we have 6 hydrogen in here, we need to put 3 in here. So now hydrogen is balanced, sulfate is balanced, Fe is balanced, and hydrogen is balanced. So that's balanced. Next one is going to be H3PO4, which is phosphoric acid, plus CaOH2, which is calcium hydroxide. It's going to give us Ca3PO4 calcium phosphate plus water. So we have PO4, we have 2 of them in here, and we have 1 in here. So I'm gonna just place 2 right away. And we have 3 calcium atoms here. We need to put 3 in here as well. So let's see. Calcium's 3. Some 3. PO4, we have 2 and 2 here. We have 6 hydrogen in here. And 6 in here is going to be 12. So we need to place 6 for water. So we have let's check the oxygen. 2 times 4, 8. 3 times 2, 6. So it's going to be 14. In this side we have 8, 2 times 4, and we have 16 is going to be 14. So that's balanced. So we need 2 moles of phosphoric acid to react with 3 moles of calcium hydroxide to produce 1 mole of calcium phosphate and 6 moles of water. Next one is ammonia plus O2 gives us N2 plus H2O. So we need to place 2 right from the beginning in here. Then we have 2 times 3 is 6, so we need to put 3 in here. Now nitrogen is balanced, hydrogen is also balanced. Oxygen we have 1 in here and 2 in here, so we need to place 2 there, half there. Then we multiply everything by 2, so it's going to be 4 NH3 plus O2 gives us 2 N2 plus 6 H2O. That's going to be balanced now. Next one is Ca3PO4 plus SiO2 plus C, CaSiO3 plus CO plus P. Phosphorus we have 2 in here, we have 1 there, so we need to place 2 there. Calcium we have 1, we have 3 in here, so we need to place 3 in here. So Ca3PO42. So 3 CaSiO3 plus CO plus 2P. Si we have 1 and 1. Oxygen we have 4 times 2 8 plus 2 10. Here we have 9 plus 1 10. We are good with that one. Carbon is balanced. Phosphorus is balanced. Calcium is balanced. So the reaction is balanced as you see in here. Next one, C6H6, which is benzene plus O2. Right away we're gonna say that's the combustion reaction. So if we have enough oxygen, we have complete combustion. So the product's gonna be CO2 and water. So we need to have 6 in front of CO2. So 6 CO2 plus we need to have 3 H2O. So now carbon atoms are balanced, 6 and 6. The hydrogen atoms are balanced, 6 and 6 again. What about oxygen? On the product side, we have 6 times 2, 12, plus 3 is going to be 15. So we need to have 15 over 2. So now multiply everything by 2. C6H6, that's 15, O2, 12, CO2 plus 6 H2O. So now it is balanced.